Okay, so tomorrow you guys are going to do a titration, and a titration is not just used for acids and bases. You can use it for oxidation reduction. You could use it with conductivity. What is a titration? A titration is when you take a solution of known concentration to determine the concentration of an unknown solution. So what we're going to do is we're going to do an oxidation reduction to determine the concentration of potassium permanganate. Now, potassium permanganate is purple. Okay, potassium permanganate is purple. That's a stupid little thing, but you know what? That was actually on the AP exam one year. Okay, potassium permanganate is purple. And so we're going to put potassium permanganate in this burette. Remember, when you put the solution into the burette, what I recommend is that you fill it past the 0 mark, and then what you can do is open the stopcock and let some of this solution just kind of flush out if there was any water right here in the stopcock or any gas bubbles. Okay, so open the stopcock until the level, the meniscus goes down to 0. Okay, and then you can start at 0. Okay, all right. Now, what we're going to do is we're going to take 10 milliliters of iron 2 solution, and we're going to acidify it by adding 10 milliliters of sulfuric acid. Okay, that's going to go right here. And what's going to happen is the iron 2 is going to be oxidized to iron 3. The only way that this can happen, number one, is by adding potassium permanganate to it. Okay, you're going to open the stopcock and get the drips going down at a steady pace. Okay, and what happens is iron 2 oxidizes into iron 3, and the only way that you can oxidize is by losing an electron. Okay, remember oxidation is the loss of electrons. Now, what's going to happen to potassium permanganate? First of all, potassium is just a spectator ion. But permanganate is going to be reduced from permanganate, that's purple, to Mn plus 2. And the way that happens, well, it's going to gain 5 electrons. Okay, this is called reduction. Remember, reduction is the gain of electrons. Oxidation is the loss of electrons. Oil rig, remember that? Okay. Now, notice that permanganate is purple, and then once it gets reduced, it's not purple. So every time a purple drop comes down here and lands in this beaker that has acidified iron, the purple drop is going to turn clear. It's going to turn clear, it's going to turn clear. As long as there's iron, it will turn clear. But once I run out of iron, the purple drop will enter the beaker and the solution will turn purple. That's our endpoint. That tells us that we're done. And that's where you close the stopcock. Now, this is the entire reaction that takes place. Notice that one iron oxidizes and gives off 1 electron. But permanganate, one permanganate needs 5 electrons. So that means that it takes 5 irons to completely reduce 1 permanganate. So it's a 5-to-1 mole ratio. Okay? Now, this solution right here is going to be the solution that we know the concentration of. It's going to be 0.1 molar. And remember, molarity is equal to moles divided by liters. So if we know the liters of iron 2 and we know the molarity of iron 2, then we can figure out the moles of iron 2. And then if we know the moles of iron 2 and it's a 5-to-1 mole ratio, then we can determine the moles of permanganate. And if we know the moles of permanganate and the volume of permanganate that it took to get to the endpoint, then we can determine the molarity of the potassium permanganate solution. That's what we're going to do tomorrow in the lab.